Okay, Algebra 2, this is still Unit 7 and Day 3, and we're now on page 3. So in Problem 2, we're talking about adult unicorns, and the length of their horns are normally distributed with a mean of 12.1 centimeters and a standard deviation of 1.04 centimeters. And in Fairfax County, we have an imaginary population, but I'm pretty sure your worksheet says 800 unicorns. So let's change that to 800 unicorns. So we are going to label our normal curve with the mean in the middle, the mean of 10.1, and then we're going to label 3 standard deviations above and below. Okay, so our numbers are going to be 11.14, and 12.18, 13.22. And then below 9.06, 8.02, and 6.98. So in problem 2, it says what percent of adult unicorns have horns shorter than 10.1 centimeters? And you can see 10.1 is your mean, so that means 50% on each side. So 50% shorter and 50% longer. Alright, for number 3, we want to shade the probability of being longer than 9 centimeters. So you have the same numbers, and here's your mean of 10.1. And this here was 1 standard deviation below the mean, and it was 9.06. So if you are going to be longer than 9, then it's going to start a little bit before 9.06, and longer than 9 is going to be everything over here. Okay, so you're going to start the same way as before, but the trick is this time we're looking for longer than 9 centimeters instead of shorter. So we're going to start by finding the probability that you're less than 9 centimeters. We're going to find the z-score, and that's 9 minus 10.1 over 1.04. And the z-score is negative 1.06. And that's going to tell you that the probability that the unicorn's horn is less than 9 centimeters is 0.1446, or 14.46%. But remember that if that's the purple part over here, if that's the white part over here, 14.46%, and the whole area under the curve is 100%, you can subtract from 100% to find the purple part over here. So I can do 1 minus 0.1446, or I can do 100% minus 14.46% to find the percentage of unicorns whose horns are greater than 9 centimeters. So that would give us 85.54%. And then, if I want to find exactly how many unicorns in Fairfax have horns that are longer than 9 centimeters, I can multiply my decimal, 0.8554, times the total number of unicorns in Fairfax, which is 800. And that's going to tell me, let's see, that I have 684 unicorns with horns longer than 9 centimeters. Okay. Now for problem 4, we're going to look for unicorns that have horns between 9.5 and 10.5 centimeters. So remember that in the middle we had 10.1, so 9.5 is going to be below the mean, and it's not a full standard deviation below, so it's somewhere in here. And 10.5 is going to be above the mean, and it's not a full standard deviation above the mean, so somewhere in here. So we're going to look for this in the middle. Now the way you do this is we are going to subtract probabilities. So we're going to find the probability first that the horn is less than 10.5 centimeters. So we'll find your z-score. And your z-score is 10.5 minus 10.1 over 1.04. And your z-score is 0.38. Then you want to look at your z-score table and find 0.38, and the probability that you are less than 10.5 centimeters is going to be 0.6480. And then you're going to find your z-score for 9.5. That's 9.5 minus 10.1 over 1.04. And your z-score for 9.5 is negative 0.58. And that's going to tell you that the probability that you are less than 9.5 centimeters is 0.2810. Okay, so less than 10.5 was 64.8%, and less than 9.5 is 28.1%. So if you subtract those two probabilities, you will get the probability that you are between the two values. So you want to write those words, subtract the probabilities. And we're going to subtract 0.6480 minus 0.2810. And we're going to get the probability is 0.367. That doesn't seem to make sense. Yes, it does. 0.367, which is 36.7%. Alright, and we have just one problem left, so we're just going to go right to the next page on this video. And in problem 3, we are going to compare two different scores on two different tests. So Emily earned 85% on the biology test, and it had a mean of 80% and a standard deviation of 6%. And then Janice earned 83% on the chemistry test, and that had a mean of 75% and a standard deviation of 7%. So what we're going to do is compare the student z-scores to determine which score was better. So for Emily, we're going to find the z-score, and that would be her score of 85 minus the mean of 80, and divide that by the standard deviation of 6. And we get a z-score of 0.83. And then for Janice, we're going to subtract her score, 83, minus her mean, 75, and divide that by her standard deviation of 7, and her z-score is 1.14. So statistically, Janice's score is better because she has a higher z-score.